Hello again, my friends. We were trying to explain different load sizing heuristics associated with the load sizing decision, and we have said that we are going to start with the simplest of those, the load for load approach. Okay, this is a very, very simple and fundamental approach which requires no complex calculation, my friends. And in the load for load approach, basically we release the order of an item exactly at the quantity and the time that they are required. Okay, so our objective in the load for load approach is to eliminate the ending inventories in the end of any period. Okay, so the units, the inventory units, are going to be ordered or manufactured only when they are needed, and the future requirements are not going to be considered, they are not going to be anticipated. Actually, here's this idea. If you are just going to initiate a production or release an order regarding to the demand of a certain period, why shouldn't you consider the future demands in the future periods? Because when you combine all of these demands, you can release a single order combining all of them, which will make you pay only a single fixed ordering cost for a single order release. However, this is just going to be considered in the following heuristic algorithms that we are going to study. As I have told you, load for load approach is very fundamental just to understand the nature of this problem, how to solve this using a heuristic. We are going to stick with this simple approach, and we will not consider any future demand. We are just going to release an order by considering our current period. And by that approach, obviously, there will be no zero ending inventory. So there will be zero ending inventory in the end of all periods. Now, the load for load technique should be used if the supplier agrees on that, because that requires the flexibility of the suppliers. I mean, for different order sizes at different periods in the planning horizon, the supplier may not actually adapt such a dynamic ordering policy. So if the supplier is reliable in delivering the orders in time and at the quantity that you want, if they are flexible to deliver the goods at any quantity, and if they are flexible in making frequent deliveries, in that case, the load for load technique can be adapted between a supplier and the customer. Now, if the fixed order release costs, ordering costs are so large, or the production setup costs are so significant, in that case, this approach is not going to yield you a very good solution, my friends, unfortunately. But as I have told you, I mean, load for load method does not have a competitive advantage uh, compared to the other heuristics that we are going to study, but we are going to understand this problem by using this simple approach. So what do we do with the load for load approach? In order to understand it, we are going to understand this question. This question is taken from Heiser's book, the production planning book. It's a very famous book, and this is a very classical question. Now, the company speaker kits here wants to determine order sizes for a certain component, and we have a 10 weeks of planning horizon. The demands associated for this component in this 10 weeks horizon, the weekly demands, are given in this table. As you can see, the demand of the first week is 35 units, then 30, then 40 units. So the demand amounts are approximately close to each other in the first 3 weeks, but suddenly it reduces to 0 in the fourth week. Then in the fifth week, it increases to 10. In the sixth and seventh week, again, it becomes stable around the same level, but again, it reduces to 0 in the eighth week. Then it becomes 30, and it becomes 55 in the last week. So as you can see, this demand pattern is dynamically changing. Even if we know the future demands, the pattern is dynamically changing here. Okay, so that's the problem we have here. For such a dynamically changing demand pattern, what type of heuristic is going to be beneficial, much more yielding, which will be yielding much more benefit. We are going to consider, we are going to try to answer this problem. So the current inventory level is 35 units, and there is no inbound inventory, we say, which means if we have 35 units, we can use this current inventory level just to meet the demand of the first week. But we need to ask the question to us about what we are going to do with the future demand in the next 9 weeks. The supplier lead time for the component is 1 week. So this is a problem usually associated with the net requirements planning, my friends. So if the supplier lead time is 1 week, then if we need to receive a certain amount of item from our supplier at a certain week, then we need to release the associated order 1 week before. I mean, that's the only complexity that this fact introduces to our problem. And we are going to see how we are going to handle this in the net requirements plan. But I mean, this part of the question is not associated with the essential parts related to the inventory management here. Okay. The unit purchase cost is constant through these 10 weeks. So the fixed cost of each order release is $100. So whenever you release an order for any quantity, you need to pay a fixed ordering cost of $100, and the unit inventory carrying cost from 1 week to the next is only $1. The question asks us to calculate the total of the ordering and carrying costs for this item based on the lot for lot policy. So what does lot for lot policy do here? So we always, I mean, solve our lot sizing problems using the lot sizing heuristics by developing such a table. Okay, so we have a table on the top of which we have the names of the weeks in the planning horizon, and we are also adding 1 week here. I'm going to explain why we add this 1 week when we are solving this problem using the economic order quantity approach for lot sizing. For other approaches, actually, we do not need to add this 11th week, but for the second heuristic that we are going to study, it is necessary. Now, the on-hand inventory in the beginning of the planning horizon is 35. So in the first row, we have the demand information as given in the question. And in the second row, we are going to write the on-hand inventory levels. And right now, in the beginning of the first week, we have 35 units of inventory. That will create a zero net requirement, obviously, in the first week, because the on-hand inventory can meet the demand of the first period. But obviously, there will be no on-hand inventory carried to the next period because it will be consumed by the demand of the first period. And in the second week, a net requirement will automatically occur. And we are going to meet the net requirement of the second period by planning an order receipt of 30 units in the second period. Okay. Now, if we do that, the same thing will happen and there will be no inventory carried to the next period. And we will be supposed to meet the net requirement of the third period, obviously. And we are going to plan an order receipt in the third week to meet that demand, so on and so forth. So this is how we apply the lot for lot approach, as you can see. So any net requirement that is written here will be met immediately and exactly. Okay, so we are going to plan order receipts at exact net requirements regarding to that period, which will force us to plan another order receipt whenever we have a positive net requirement in the following weeks. Now, in the fourth period, we do not have any demand, therefore we do not have any net requirement, therefore we do not plan any order receipt. So we are, as you can see, we need to plan 7 order receipts for these 10 weeks of planning horizon. And if we are planning these order receipts as in these weeks, then we need to release the orders 1 week earlier, obviously, because the supplier lead time is mentioned to be equal to 1 week in the problem. So this is again an irrelevant part to the inventory management part. So we are just trying to calculate the associated cost with the lot for lot approach here. Now, as you can see, in no week here, we carry a positive amount of inventory from that week to the next, okay? So all weeks will be ended with a zero level of inventory in the lot for lot approach. Remember now, this is just a plan. This does not mean that this is exactly going to happen like this, okay? This is just a plan. We are trying to develop a reasonable or acceptable lot sizing plan based on the heuristics. So in this plan, we do not carry any inventory to the next period, starting from the second period until the last period. And that means we do not carry any inventory to the next planning horizon, which starts in the end of the 10th week. And the next planning horizon is maybe it is going to be a 10 weeks plan or 20 weeks plan. We do not know. So here we do not pay any inventory carrying cost. However, since we release 7 different orders in this planning horizon, we need to pay 7 fixed order releasing costs. Okay, each order release costs a fixed amount of $100. So 7 times this, we need to pay $700 as the total ordering cost in this plan. Again, please check, starting from the second week here until the 11th one, we are not carrying any amount of inventory to the next period, okay? So from the first period to the second period, nothing is carried. From the second to the third, nothing is carried, so on and so forth. From the 10th period to the 11th, nothing is carried, which means we do not pay any inventory carrying cost. So this plan has a $700 cost when we use the lot for lot approach, my friends. Now, as I have told you, this is not the best approach usually. The lot for lot approach is just simple to understand, and we are mentioning about this just to understand the net requirements planning table here. Now we are going to use the same table again. This time we are going to solve the problem with other heuristics. The next heuristic that we are going to deal with is the lot sizing heuristic with economic order quantity, and we are going to study this in the next video.